Bismillahirrahmanirrahim. This is tutorial 1.3, question number 3. You are given one baking soda which contains sodium bicarbonate NaHCO3 is decomposed. Decomposed, it releases CO2 plus sodium carbonate plus water, which you have to write the balance equation for question number Roman 1. Okay, so this is the balance equation, which you have 2 mole of sodium bicarbonate to form 1 mole of CO2 plus sodium carbonate plus water. Then next, you have to calculate the mass of sodium bicarbonate required. So what is the mass of sodium bicarbonate required to produce 20.5 gram of CO2. So dia sudah bagi pada you the mass of CO2. So what to do is to write the proportion. So you write 1 mole of CO2. It is from this stoichiometric coefficient from the balance equation, of course, which it is equivalent with 2 mole of sodium bicarbonate. Then since you are given that 20.5 gram of CO2, so what you have to do is to find the mole of CO2. So cari mole CO2, 20.5 gram divided by the molar mass of CO2. Then once you have done the mole of CO2, you insert it here. Okay, so how many mole of CO2 is 0.466. So mole of CO2 is 0.466 is from here. Okay, 0.466 mole of CO2, which if we have this 0.466 mole of CO2, 0.932 mole of sodium bicarbonate. Since you have to calculate the mass, what to do? 2 times with the molar mass of sodium bicarbonate. So the answer is 78.29 gram. Next, let us look at question number 4. Hydrogen peroxide, which is H2O2, decomposes to produce water plus oxygen. As in the following equation given, what would be the volume of O2 released? The question is asking you the volume of O2 released from the decomposition of this mole of 2 molar of hydrogen peroxide. Okay, kalau dalam soalan dibagi dekat you is the volume as well as the concentration, berapa mil dan berapa molar. What to do is to, of course, to calculate the mole. So you can calculate mole of H2O2 by using mv per 1000. So molarity is 2.0 times with the volume 250 mil divided by 1000. So the mole for hydrogen peroxide is 0.5 mole. Then next, make sure it is a balanced equation. Is this a balanced equation? 2, 2, 4. So 2, 2, 4. Oxygen is 4. Oxygen is 2 plus 2. So this is a balanced equation. Okay, next is to write the proportion. Tulis perkadaran macam biasalah. Right. Which 2 mole of H2O2, the hydrogen peroxide, will release 1 mole of O2. Since we have 0.5 mole saja, so berapa mole O2 will be produced? How to solve this proportion? 0.5 divided by 2 times 1. So what is the answer for mole of O2 gas released? Is 0.25 mole of O2. Next, the question is asking you the volume of O2 at STP. Dia nak volume of O2 at STP. So At STP, apa nak buat? You have to times with the volume at STP, which is 22.4 liter per 1 mole kan. Okay, so per 1 mole ada 22.4 liter. Makanya the answer is of course in liter lah, 5.6 liter. So this is the volume of O2 released. Next question is question number 5. You are given methanol completely burnt in oxygen and is used as fuel. You have to calculate the mass and volume of CO2 gas produced at STP. Okay, apa nak buat? Mesti kena tulis the balance equation first. Right, okay, so tulis balance equation dulu. Methanol, which this methanol burn in oxygen to form of course CO2. Okay, combustion will produce CO2 plus water. Okay, then what's next is to of course to balance equation, right? So 2 mole of methanol plus 3 mole of O2 to form 2 CO2 plus 4 mole of water. Then next is to calculate the mole of methanol. So mole of methanol given to you is 10.9 gram. Then you have to divide by the molar mass of methanol, of course. Okay, so answer mole of methanol is 0.3406 mole. Then next, what to do is to of course to write the proportion. Okay, you nak cari siapa? You nak cari CO2 gas punya. You nak cari apa? Mass and volume. Kena minta tolong siapa? Minta tolong mole methanol, which you are given the mass. You have done the mole of methanol. So what to do is to write the proportion, of course, which 2 mole of methanol. Okay, 2 mole of methanol equivalent with or release berapa mole of CO2 is 2 mole of CO2. Since berapa mole just now? If we have 0.3406 mole of methanol only, so dia akan produce how many mole of CO2? Dia akan produce juga mole yang sama lah, kan? 2 dengan 2 mesti sama lah, 0.3406 mole of CO2 also will be produced. Okay, once you have done the mole, of course you can calculate the mass. As usual, you have to times with the molar mass of CO2. So answer is 14.99 gram. That is the answer for mass. How about the volume? Volume dia nak produce at STP. Makanya daripada mole tu nak buat apa, kelas? 0.3406 mole you times with the berapa liter dekat STP is 22.4 liter per mole. Okay, 22.4 liter per mole. You cancel off mole and mole, negative 1. Then ini apa tadi? Volume of CO2. Tulislah apa benda you dah cari. Okay, so volume CO2, the answer is 7.63 liter. So that is the answer for mass and volume of CO2 for question number 5. Let us proceed to next question, question 6. You are given the combustion of copper 1 sulfide produces copper 1 oxide and sulfur dioxide gas, which you have to write the equation. So question A is to write the balance equation. Right, okay, then kita ada apa tu? Kita ada Cu2 as copper sulfide, okay, plus O2 to form Cu2O copper oxide plus sulfur dioxide gas. Question A. Question B, you have to calculate the number molecules of oxygen gas reacted. Right, berapa molekul O2 yang sudah reacted? If you are given 14 gram of copper sulfide, so what to do? To calculate the mole of copper sulfide first, which is 14 gram, then you divide by the molar mass of copper 2 sulfide. Okay, then the answer mole of copper 1 bukan copper 2, silap, copper 1 sulfide. Okay, copper 1 sulfide, the mole is 0.0879 mole. So that is the mole of copper sulfide. Next is to, as usual, write the proportion. Right, okay, then 2 mole of Cu2S is equivalent with or reacts with that 3 mole of O2. Since it is only 0.0879 mole of Cu2S, so this mole will be will react with berapa? 0.132 mole of O2. So again, how can we solve this proportion? Is to divide by 2 times 3. That is how you solve the proportion. Okay, next, once you have done the mole of O2, you have to calculate the number of molecules by times with the molar mass. Times with the Avogadro. Untuk dapatkan number molecules of O2 gas reacted, okay, mole of O2 mass times with the Avogadro number. So the answer is 7.95 times 10 22 oxygen molecules. Okay, so this is the answer, 7.95 times 10 22 O2 molecules. Then next is to find the mass of SO2 gas produced. Dia nak berapa mass of CO2 gas produced. Again, you have to write the proportion which 2 mole of copper 1 sulfide equivalent with or produce also 2 mole of SO2, the same mole kan, dua-dua. Makanya since we have that 0.0879 mole of Cu2S, so benda yang samalah juga, 0.0879 mole of SO2 also will be produced kan, sebab 2 dengan 2, so samalah. Okay, then next is to, yang ni barulah kita times with the molar mass of SO2. Then the answer is 5.63 gram. So that is the answer for question A and B. Let us proceed to question number 7. Mangan 4 oxide reacts with hydrochloric acid gas according to the following reaction. In one experiment, you are given 75 gram of mangan 4 oxide and 50 gram of HCl gas are allowed to react. So you are given the mass for both reactants. Kan? Okay, so what to do is to, of course, to calculate the mole for both reactants. Kan? Okay, then tulis apa? Tulis MnO2 equals to 75 gram divided by the molar mass of MnO2. Answer of MnO2 is 0.863 mole. How about mole of HCl? The same goes. You are given 50 gram divided by the molar mass of HCl. So answer HCl is 1.37 mole. So ni mole apa ni? This is mole provided ataupun mole available. So these two are mole provided or available mole yang ada lah, yang diberi asalnya kan, mula-mula. Okay, then check. Is that a balanced equation given to you in the question? Check. So Mn1, O is 2, yes. For HCl, for mole of HCl, so Cl2, oxygen 2. Okay, so this is a balanced equation. Sudah balance, then lebih senanglah kerja kita. Okay, next is to write the proportion kan. Then from the stoichiometric coefficient, berapa mole of MnO2? Is 1 mole of MnO2 divide 1 mole of MnO2 reacts with 4 mole of HCl. Then tulislah the proportion perkadaran MnO2 equivalent with or reacts with 4 mole of HCl. Okay. Since we have berapa mole provided just now is 0.863 mole of MnO2 provided or available, this will be equivalent with how many mole of HCl? It is 3.452 mole of HCl needed. Itu adalah mole apa tu? Mole needed. This is mole needed. How to solve this proportion? 0.863 mole divided by 1 times 4. That is how you solve the proportion to get what is the mole of HCl here. Okay, tadi berapa mole HCl available? Is 1.37. What is the mole needed? Mole needed is 3.452. Right. Okay, dalam poket ada RM1.37. Okey, yang ada dalam poket RM1.37. Tapi kita perlu nak beli barang RM3.45. Duit cukup tak? Tak cukup. Sebab dalam poket hanya ada RM1.37 je. Sedangkan kita nak RM3.45 nak beli barang. Right, okay. So, bila tak cukup, siapa habis dulu? Therefore, HCl is the limiting reactant. HCl is the limiting reactant. Okay, before we come up with this statement, mesti kena buat apa? Mesti kena compare mole HCl available yang ada dalam poket. Is bukan mole, less. Okay, yang ada dalam poket lebih sikit daripada mole HCl needed. Okay, then marks kat mana tau? Package of this both mole betul 1. The proportion is 1. You come with the statement limiting reactant ni satu lah kan. Okay. Compare mole 1. Then next, this is question Roman 1. Question Roman 2. Roman 2, you have to calculate the mass of Cl2 produced. So what is the mass of Cl2 produced here? Okay, kat sini. Dia nak mass ini. So, mass of this product of Cl2 ini mestilah will be based on berapa HCl yang kita ada. Why? Because this limiting reactant will limit the amount of the product form. Banyak mana duit ada, banyak itulah barang yang kita boleh beli. Right? Okay, so the key here is to write the proportion between the limiting reactant with the product Cl2. So, tulis 4 mole HCl equivalent with berapa mole tu? 1, right? Okay, then di sini 1 mole. Then 1 mole of Cl2. Berapa available tadi? Hanyalah 1.37 mole sahaja HCl, which this mole of HCl will be equivalent with, dia akan produce how many mole of Cl2? Is 1.37. You divide by 4, you times with 1. So, answer is 0.3425 mole of Cl2. Since you have to calculate mass macam biasa, times with the molar mass of Cl2, then the answer is 24.32 gram of Cl2 produced. Next is question number 8. A reaction between 20 gram of aluminium. You are given 20 gram of aluminium and the volume as well as the concentration of sulfuric acid, 300 ml of 0.5 molar of sulfuric acid produces aluminium sulfate, Al2SO43 and hydrogen gas. 8A, you have to define what is limiting reactant. So what is limiting reactant? Refer to the lecture note. Limiting reactant is the reactant that is completely consumed. Yang habis dulu, completely consumed during a reaction, and it will limit the amount of the product formed. How about question B? To calculate the mass of excess reactant after the reaction. What to do? First is to, of course, to write the balance equation first. So you write the balance equation first. Al plus sulfuric acid to form aluminium sulfate, given the formula up there, Al2SO4 3 plus with that hydrogen gas. Then you put 2 here, 2 mole of Al with 3 mole of H2SO4. Then sulfate you have 3, right? Then what's next? H2 is 6, so put 3 here. Then this is the balance equation. So 2 mole of aluminium reacts with 3 mole of sulfuric acid to form 1 mole of aluminium sulfate plus 3 mole of H2 gas. Okay, then next is to calculate the mole for both reactant. So mole for aluminium is, as usual, the mass divided by the molar mass of Al. So the mole for Al is 0.741 mole for aluminium. How about mole of sulfuric acid? It is mv per 1000. Then you insert the molarity is 0.5 times the volume is 300 divided by 1000. To get it is in liter, then the mole of sulfuric acid is 0.15 mole. Mole for both reactants. Then from the equation, 2 mole of aluminium reacts with 3 mole of sulfuric acid. Since we have provided mole is, what is the provided mole? Mole yang ada dalam tangan 0.741 mole and 0.15 mole of sulfuric acid. So these two are the available mole, right? Okay. So if we have that mole of aluminium is 0.741 mole only. So how to solve this? Divide by times 3. Okay, then you have the mole of sulfuric acid is 1.111 mole of sulfuric acid. So what is this mole of sulfuric acid? Is mole needed, kan? So kalau kita ada this 0.741 mole of Al, so 0.741 mole of Al will need 1.111 mole. Apa available tadi is 0.15. Dalam poket ada 15 sen. Perlu RM1 11 sen. Right, cukup tak? Tak cukup. So bila tak cukup, siapa habis dulu? Sulfuric acid. Okay, therefore sulfuric acid is the limiting reactant. But before that, kena buat apa kelas? Kena compare mole. Mole sulfuric acid available is less than, yang ada dalam poket less than yang needed. Mole sulfuric acid needed, tak cukup. So bila tak cukup, sulfuric acid habis dulu. Dia adalah limiting reactant, while Al is the, therefore Al is the excess reactant. Oh, tapi soalan nak mass of excess reactant lah, kan? Dia bukan nak suruh determine the limiting reactant. But still we have to determine the excess reactant lah, Al kan? So aluminium. Okay, since sulfuric acid is the limiting reactant, kan? Okay, then you have to write a new proportion, which 3 mole of sulfuric acid. Kita kena start dengan sulfuric acid lah. Sulfuric acid is the key. H2SO4 is the key. Why? Because it is the limiting reactant, which will limit the amount of the product formed. Dialah kunci. So start, write the proportion, okay, start dengan sulfuric acid, which this is equivalent with 2 mole of Al. Right. So since 3 mole equivalent with 2 mole of Al, tadi kita ada berapa je? Yang provided is 0.15 mole of sulfuric acid. So kalau ada banyak ni je, 0.15 mole, dia perlu berapa mole of aluminium? Perlu berapa mole of aluminium? So berapa mole aluminium needed? Here the answer is 0.1 mole of aluminium needed. Dia perlu banyak tu je lah. Dia perlu banyak ni je sebab dia dah habis. Dia ada banyak ni je. Dia ada banyak ni je. 0.15 je. So dia perlu 0.1 mole. Kan? Okay. Tadi kita ada berapa mole asal? Mole asal is ini. Available. So apa nak buat? Kena tolak lah. Right. Dapatlah mole excess. Therefore, and aluminium excess, tolak, equals to 0.741 minus that 0.1 mole. Okay, ni kat sini ya. Ni mole excess of aluminium. Okay, so 0.741 minus 0.1 equals to 0.641 mole excess. Tapi dia nak mass. So what to do with this mole is to times with the molar mass of aluminium. Answer final is 17.31 gram of aluminium. Okay. How about question C? Question C, you have to determine the percentage yield if the mass of aluminium sulfate obtained from the reaction is 16.5 gram. What is that? That is the actual mass. So that is actual yield. Ini diberi pada you is actual yield. Actual yield. Okay, berapa mass dia is 16.5. Okay. Nak tulis apa ni? Next is to write the proportion between the limiting reactant with aluminium sulfate produce. Berapa mole aluminium sulfate produce is depend on berapa banyak limiting reactant yang kita ada. Banyak mana limiting reactant ada, banyak itulah produk yang akan terhasil. Kan? So what to do is to write the proportion of 3 mole of sulfuric acid equivalent with 1 mole of aluminium sulfate. Since provided tadi berapa? Available ada 0.15. Therefore, if we have 0.15 mole of sulfuric acid, it will produce this divided by 0.15 divided by 3 times 1. So answer here, mole of aluminium sulfate is 0.05 mole of aluminium sulfate. Baru mole. Kan? Okay, theoretically nak buat apa? Theoretically kena cari mass of aluminium sulfate produce. Daripada mole kita convert kepada mass. So you have to times with the molar mass of Al2SO4 3. Okay. So untuk convert kepada mass, you darab dengan molar mass. Then the mass theoretically yang sepatutnya kita dapat is 17.12 gram. This is theory. This is theory yield yang sepatutnya kita dapat secara teori based on the stoichiometric coefficient. Kan? Okay, based on the stoichiometric coefficient here, we should get this 17.12 gram. Tetapi actual kita dapat banyak mana je ni? 16.5 gram je. So, nak tulis apa? Next is to write the formula of percent yield. Percentage yield equals to actual yield divided by the theory yield times 100. Actual tadi berapa? Is 16.5 gram divided by the theory yang sepatutnya kita dapat is 17.12 gram. You times with 100. So what is the answer is 96.38% je yang kita dapat. Kan? Kita tak dapatlah 100% 17.12 seperti teori. Kan? What other factors lead to this? Because might be due to experimental errors such as the techniques when handling the apparatus ke. Kan? Banyaklah experimental errors. Okay, then done. Question number